everyone, I'm Yue. Today I'm going to talk about unpaired face expression translation use GANs. First, come to the problem under study. Image translation is a rising field in machine learning and image processing. Image translation is to transform two image domains with different characteristics, including style transformation, object transformation, image enhancement, and so on. It has experienced the transformation from single-task image translation for a specific field to multi-domain and multi-task image translation. From the image side that need to be paired with label to the image side that only needs to be unpaired without labels. In the past several years, the general end-to-end deep learning framework, most notably that the use of full convolution network and conditionally generation adversary network has promoted the development of image translation, so that a variety of image translation problems can be dealt with uniformly. The core idea of GAN is derived from the Nash balance of the game theory. The model contains a generator and a discriminator. The generator generated an image by receiving nodes. The discriminator is discriminant network, which determines whether a picture is true or false. The model trains the generator and the discriminator alternately. The discriminator distinguishes whether the sample comes from the true distribution or the model distribution. When the discriminator finds a difference between the two distributions, the generator optimizes its own parameters so that the discriminator cannot find the difference. The generator generated more realistic sample to deceive the discriminator through training, and the discriminator continuously improve its discriminative abilities through training. After repeated training of the generator and the discriminator, the final generator can fit the distribution of the training data until the discriminator does not distinguish whether the input data comes from the generator or the real original data. The structure of GAN is shown in this figure. We can use the differentiable function g and d to represent the generator and discriminator. Random node z as the input. The generator tries to generate data that conform to real data distribution as gz. The generated sample gz and the real sample x are respectively input to the discriminator d. The discriminator data judge whether they come from generator data or real data. After reading a lot of lecture, I just want to propose a new approach. Firstly, this project mainly studied the relevant model of GAN in image translation and its application in face expression. Secondly, aiming at the problem of image translation between face image, this paper established a new network model based on star generation adversarial network model, adding loss function for its objectivity function of its generator and the discriminator. Last, through parameter optimization experiment, the model proposed in this paper is continuously optimized to find the optimal parameter. The virtual and quantitative compression experiment shows that the image translation effect of the proposed model on fixed expression is effective in terms of clarifying and maintaining facial feature. During the experiment, this project performs a classification experiment on facial expression translation and conduct a loss analysis. Besides, we compare stack GAN against recent method on facial expression translation. For data enhancement, I flip the image at a probability level of 0.5. I perform a generator update after 5 discriminator updates. The bench size of all experiments was set to 16. My experiment trained all the model with a learning rate of 0.001 in the first 10 period, and linearly attenuately the learning rate to 0 in the next 10 period. The training procedure takes 3 days on a single NVIDIA T-Tex GPU. The proposed are using TensorFlow module. The generatively adversary networks as the structure are used Python to implement the program. For the quantity evaluation, the figure shows the face expression translation result in Celeb A dataset. We can observe that our method provides extremely high visual quality of translation result on the test data than the cross-domain level. One possible reason is regularization effect of GAN through multitasking learning framework. In other words, our training model flexibly translates the image according to the label of the target domain rather than the training performance fixed translation, which is easy to overfit. This enables our model to learn reliable figures that are generally applicable to multi-image domains with different facial attribute value. I also use the model to test fictional face image while using Celeb A datasets for training. Some image datasets has some annotation attribute. For example, the Celeb A dataset contain 40 labels related on facial attributes, such as hair color, gender, and age, while the RefD dataset has 8 facial expression labels, such as happy, angry, sad, and so on. These setting attributes enable us to perform more interesting tasks. We call it multi-domain image-to-image transformation. The image is transformed according to the attribute from multiple domain. For example, in a ball figure, show how a Celeb image to convert it according to 4 domains of smell, surprise, contemptuous, angry, sad, disgusted, and love. We can also further expand training multiple domains from different data sets, such as a jointly training Celeb A and RefD image. As shown in the above figure, the features learned in the RefD training process are used to change facial expression of Celeb A image. And it's the core source code for building the model. So come to the conclusion. This paper describes the research status in the field of image translation in the recent years and proposes a face expression translation model based on generatively adversary network. In the process of research, it is found that the following problems in the field of image translation need to be further studied. We use GAN to perform facial attribute conversion and the facial expression synthesis task and made quantities and the size of the result. Although results show that the feature learned in the RefD training process are used to change the facial expression of Celeb A image, but we did not train Celeb A dataset to change the attribute of RefD image, which is an essential further work to approve the applicability of the model. Secondly, the result of the facial expression transfer is good for real people, and the conversion result to fictional face image, such as avatar imprinting, is not good enough and should be stressed. Thank you for listening.